All right, let's talk about what really separates a good engineer from a great one. And it's not what you might think, especially when we're dealing with today's complex AI systems. We're going to use a couple of real deal interview questions to really unpack that senior engineering mindset that top companies are so desperate to find.
So what is it? What's the secret sauce? Is it just about putting in more years, knowing more programming languages? Well, the answer is actually way more fundamental than that, and it's something you can start working on, like right now. And here's the thing. The whole point is this. It's not about memorizing more algorithms. It's about a complete shift in how you see the world. It's about moving on from building things that just work on your laptop to building things that can survive in the messy, chaotic, real world, in production. Okay, so to really dig into this, we're going to walk through two case studies. And these are pulled directly from actual senior-level AI engineering interviews. This is where the difference between a simple demo and a system that's built to last becomes crystal clear. This is it. This is the core difference. A mid-level engineer is focused on proving that something works. A senior engineer, they're trying to prove it won't break. They're already picturing that 2 a.m. phone call when traffic has gone through the roof and some random service just decided to fail. That's the mindset we're talking about.
All right, first one up. I want you to imagine you're in an interview, and they hit you with this design challenge. It seems pretty straightforward on the surface, but all the hidden layers of complexity are where you really get a chance to show what you're made of. So here's the task. Build an automated support bot. It's got to do a few things in order. Read a support ticket, figure out what the problem is, find the right information to fix it, and then write up a reply. And the big question is, how do you build it? As one single giant AI agent, or as a team of smaller specialized agents? Now, this is the answer that so many people give. And look, it's not technically wrong, but it's incomplete. Just saying it's more modular is a classic mid-level response because it points out a benefit without even thinking about the cost. And trust me, modularity isn't free. But see, a senior candidate, they don't even think about a solution yet. They start by asking questions. Things like, what kind of ticket volume are we expecting here? How fast does this thing need to respond? Are there any legal or compliance rules we need to worry about? They're gathering all the context before they even start to sketch out an architecture.
And once they have that context, then they can start talking about the trade-offs. A single agent is fantastic for simple step-by-step tasks where every millisecond counts and you want as little overhead as possible. But a multi-agent system? That's where you get your resilience. That's how you make sure a problem with one part, say the ticket classification, doesn't bring the whole system crashing down. And this right here is a huge red flag for interviewers. Any answer that uses absolute words like always or never is a dead giveaway that you're thinking about perfect world demos, not real world production systems. The right answer is always, well, it depends. Okay, on to our second question. And this one builds right on top of the first. Let's say you chose the multi-agent approach. The interviewer is going to dig deeper. They'll ask, okay, so how do you organize that team of agents? And just like before, there's a superficial answer that's easy to fall for. A candidate might say that having a planner agent and an executor agent is just, good organization. It makes the code tidy. And yeah, it does. But that completely misses the most critical, mission-critical reason for this design pattern. So first, let's define these roles. The planner. Think of the planner as the brains of the operation. It's the project manager. It knows the overall goal, it keeps track of everything that's happening, and it breaks down big problems into small, manageable tasks for its workers. And then you've got the executors. These are the hands. They're the specialized workers. Each one just does one specific thing, like searching the web or talking to a database. They have a really narrow focus, and, this is super important, they're designed to be completely stateless and replaceable. Basically, they're disposable. Okay, so why go to all this trouble? It's not just to make the code look nice. The real magic of this planner-executor pattern shows up when the system, inevitably runs into a problem out in the wild. And here's the payoff. Let's watch it happen. The planner assigns a web search to one of its executors. But oh no, that executor fails. Maybe the API it was trying to call is down. Because the planner is tracking everything, it sees the failure. It doesn't crash. It doesn't panic. It just says, okay, no problem, and reassigns the exact same task to a different, healthy executor. And the whole thing just keeps on going. The end user has no idea anything even went wrong. That is failure isolation.
So what have we learned from these two questions? What's the big idea here? Well, they both point to this one single overarching principle that really defines that production-ready mindset. First off, they're always thinking about scale. They're not just building for the traffic you have today, they're building a system that won't fall over when that traffic suddenly spikes by 10 times. That thinking is baked in from day one. Second, and this is so important, they expect things to fail. They don't just hope for the best, they actively plan for the worst. That whole planner-executor pattern we just talked about, it's built entirely on the assumption that things are going to break. And finally, they get that every single architectural choice is a trade-off. Nothing is free. You want that awesome resilience from a multi-agent system? Great, but it's going to cost you in latency and complexity. A senior engineer lives and breathes in that world of costs and benefits. All right, so let's boil this all down. What's the big takeaway for you? When you're facing these kinds of system design questions, what does it really mean to think like a senior engineer? Well, it means you're the person who always asks those clarifying questions first. It means you speak fluently in the language of trade-offs, not just benefits. It means your brain is constantly focused on reliability and what happens when things go wrong. And maybe most of all, it means that every cool design pattern you talk about is tied directly to a real-world production problem. And that's really the question to leave with. The next time you're building something, or the next time you're in that interview, ask yourself this: am I building a cool demo for a perfect world, or am I building a system that can survive a crisis at 2 in the morning? Because that distinction,